Welcome to The Explainer. Today we're diving into something that's, quite frankly, fascinating. We're looking at the rapidly evolving world of assessment, and we're going from the massive global scale of AI all the way down to a deeply personal hurdle for a lot of people, university applications. You see, the way systems evaluate potential is totally changing right before our eyes. We're going to explore how these systems, both technological and institutional, are suddenly demanding highly structured data. It's a really brilliant look at how navigating the future requires a completely new way of structured thinking. Okay, let's dive into this. Here's our roadmap for today. First, we'll ask, what actually are neural networks? Then we'll look at the promise of AI, followed by its ethical dilemmas. After that, we're shifting gears to the 2026 UCAS overhaul. And finally, how to master the three questions. Right. Let's kick things off with Section 1. What are neural networks? To understand where technology is pushing us, we really have to grasp the core mechanics of artificial intelligence. We're actually pulling some foundational insights here directly from IBM. So, what makes a neural network so special? Well, it isn't just a basic computer program. It's a machine learning model that literally stacks simple neurons into complex layers. Think of it kind of like a giant, highly sophisticated filter. It mathematically maps raw input data, let's just call it X, to a predicted output, Y. The real magic is in those structured layers. They give the AI the ability to make incredibly complex leaps in logic that older algorithms just couldn't even touch. It's all about taking an input, filtering it through those structured layers, and boom, generating a highly accurate output. Moving on to Section 2, the promise of AI.
Now that we've got the mechanics down, let's look at what these structured networks actually achieve out there in the real world. AI absolutely excels at tasks that require crazy amounts of granular detail. Take oncology, for instance. AI systems are now spotting early-stage malignancies, like melanoma, with just staggering accuracy. What about finance? It's drastically slashing the time it takes to process massive data sets. And, because these systems don't need a coffee break or a good night's sleep, they offer continuous, round-the-clock customer support. At the exact same time, they're helping researchers rapidly simulate scenarios to discover new pharmaceuticals, and even tracking wildfire risks and endangered species from space. I mean, it's totally revolutionizing how we process the world around us.
But that brings us to Section 3, AI's ethical dilemmas. Now, what's really interesting here is that this incredible power obviously doesn't exist in a vacuum. To look at this double-edged sword objectively, we're grounding our discussion in a peer-reviewed study from the International Advanced Research Journal in Science, Engineering, and Technology. And this brilliantly illustrates the stark contrast we're dealing with. We're absolutely looking at a classic double-edged sword. On one hand, you have extreme precision in healthcare, but on the flip side, algorithmic biases can actually amplify unfairness in things like hiring or law enforcement. We get these massive productivity gains, sure, but we also face the very real, very scary danger of severe job displacement as automation replaces human labor across whole sectors. And while AI is fantastic for tracking environmental conservation, the massive data centers required to run these models, they consume staggering, almost unbelievable amounts of water and electricity. And then there's the sheer cost of it all. According to OpenAI CEO Sam Altman, training the GPT-4 model cost more than $100 million. Let that sink in, 100 million. That is an immense barrier to entry. Developing generative AI requires resources, infrastructure, and elite technical expertise that, let's face it, most organizations simply do not have access to. So, this brings us to a vital thematic pivot for us today. If machines are getting this incredibly advanced at mapping inputs to outputs, and if institutions are increasingly relying on highly structured data, how do human students prove their unique value? How on earth do we prepare ourselves to be assessed in a future that is this automated? Well, that leads us perfectly into Section 4, the 2026 UCAS overhaul. 3. That is the magic number for anyone applying to universities in the UK for the 2026 entry cycle, drawing from some great guidance provided by Leading Tuition. The traditional, unstructured, free-form, 4,000-character personal statement essay, it is officially dead, completely gone. Instead, it has been replaced by exactly 3 highly structured questions. It's fascinating, right? Just as AI models require highly specific, layered inputs to function, human institutions are now demanding similarly structured, specific inputs from their applicants. Which brings us to our final part, Section 5, Mastering the 3 Questions. Let's move to the practical side and see how this builds. How do you actually adapt to this? Well, the new UCAS format breaks down into roughly 500 words across 3 distinct layers.
Question 1 asks why you want to study the subject, and you've got a strict 150-word limit. Question 2 is the bulk of the work, about 250 words on exactly how you've prepared. And question 3 is a super tight 100 words on how the degree will achieve your ambitions. Just like the neural networks we talked about earlier, this new system demands highly specific, layered inputs. So let's break each one down. For question 1, with only about 150 words to play with, every single sentence literally has to pull its weight. Admissions tutors read thousands of these, so please avoid the invisible cliches. You know the ones, "I've been fascinated by economics since I was a toddler." It tells them absolutely nothing. Instead, get hyper-specific. Name a specific book, a research paper, or a niche problem in the field that actually sparked your genuine intellectual interest. Moving to question 2. So, the crucial point here is that this is your ultimate differentiator, especially if you're aiming for highly competitive spots like Oxbridge or medicine. At 250 words, you absolutely have to show, not just list. Don't just drop a random laundry list of extracurriculars. You need to prove university-level engagement. Talk about an extended project qualification, a specific clinical shadowing experience, or some advanced academic reading you did. You've got to explain what you engaged with and, more importantly, how it actually evolved your thinking. Finally, question 3. This is a test of realistic ambition in just 100 precise words. Do not use vague corporate filler like, "I want to make a positive impact on society." Everyone says that. Instead, draw a direct, plausible line between the analytical toolkit you'll gain from this specific degree and where you actually want to go in life. Connect the specific skills to the specific destination. So, from the mathematical weights and structured layers of AI neural networks, all the way to the strict 500-word constraints of the new UCAS application, the trend is pretty undeniable. We are living in an era that demands absolute precision. Vague essays and uncontextualized data, they simply don't cut it anymore. So I'll leave you with this to think about. As both machines and institutions move toward highly structured assessment, how will you design your inputs to guarantee the best output? Thanks so much for joining me for this explainer, and I will see you next time.